Okay, so now that we've discussed the use of a single micro switch with the microbit itself, what I'd like to do is talk about using them in pairs. So I find, a limit switch can be very handy to know the end of travel. So for instance, if you had, let's say a 3D printer, you have your three axes, you have X, Y, and Z. And usually they're run on some sort of a threaded bar, for instance. Now, the machine itself doesn't know when it gets to the end of the bar without having an additional sensor. Usually, it's a limit switch. So when that, let's say the extruder head moves all the ways over to one side, before it crashes in and keep burning out the motor trying to go where it can't go, it usually hits something like a limit switch. And that tells the machine that it's at its end of its travel and it must go back because it can't go any further this direction. And usually on the opposite end, then there's a separate one. So then when it hits here, then it knows that's the end. And when it comes over here, it knows that's the end on this side. So you can find it very handy for a function like that. Now, for this demonstration, I'd like to show you how we're going to wire it up with two of the micro switches. But instead of linear motion, we're going to talk about rotary motion. So here we have a motor, we have a gearbox. We're going to have a high rate of, I suppose, rotation from the motor itself. It's going to be geared down through this gear train. And then we're going to have a lower, I suppose, revolution rate right here, so RPM. And it's going to be more, I suppose, more torque on it. Now we're going to attach two pencils to the end of this shaft. And what's going to happen as this swings all the ways to one side, it's going to hit one of our limit switches. And then it's going to know to go all the way back and hit one of the other limit switch or the other limit switch on the opposite side. Now to do this, what we're going to do is we're going to follow this wiring diagram here. It's going to be fairly simple, very similar to what we've done previously. So if you imagine getting rid of the green line here and all this over here, and it's similar to what we had previously as well as this. Now this time we're just adding in a second limit switch. They both share the same ground, but we have separate pins. I'm using pin 1 here and pin 0. Just ensure the pins that you've selected are analog pins. And then I'm just going to use motor block 1, although you can use any motor block as long as you know which one it is for the code itself. So what we'll do now is we'll jump over and we'll have a look at the code before. Okay, so now that we've moved over to our microbit code editor, what we can do, like always, we'll delete our on start because we won't need it in this particular line of code. We can start off by making our variables similar to last time. This time we're going to need two separate variables, one as limit switch 1 and the other one as limit switch 2. So limit switch 1, and then we're going to have a second one, limit switch 2. Like so. Then what we can do is we can put our set limit switch, and then we can duplicate that, and we can make one as limit switch 1 and one as limit switch 2. We can use the two pins that we've decided to use according to our wiring diagram. As previously discussed, we're going to be using pin O and pin 1. So I'm going to go down here, I'm going to find my pins, I'm going to go to analog read pin O, I'm going to duplicate this, and I'm going to make this pin 1. Now what we need is we need some extensions because we know we're using our Keytronics all-in-one breakout board, and we're going to be using the motor blocks. So we don't have them normally here. So we can go to extensions, we can go to all-in-one, and this should pop up the Keytronic robotics board. You can click on that, and you see now that we have robotics, and under this we have additional motor blocks. But before we pick them, we're going to go for our logic blocks, which you can see below here, and we're going to go for if true, and we're going to drop that in like so. Now that we have that done, what we can do is go back into our logic, and we can go for our comparison block, drop that in, and then we can start adding in our variables. So we'll go limit switch 1 here. So if limit switch 1 is equal to 0, then this happens, and what we want to happen is for our motor to turn forward, and it's going to be motor 1, and we're going to say at full speed. So we'll go for motor 1, so we know we're using motor block 1, it's going forward, and it's going 100% power. We're going to add an additional one because we have a limit switch 2 as well, which is for pin 1. I just drop down the second menu here, and you see we can drop in our comparison block again. We'll duplicate that, we'll drop it in like so. We'll change the limit switch 1 to limit switch 2, and say if it's equal to 0, then motor 1 turns the opposite direction. So we'll say reverse. Now what we can do is we can go back here and we can close this one down, so that's out of our way. And everything we have here should work fine. So if we run through from the top, it knows that switch 1 is pin 0, it knows switch 2 is pin 1. It knows that switch 1, if it's equal to 0, that means it's pressed in, and that the motor 1 goes in direction forward at 100% speed. Then we know if limit switch 2 is equal to 0, so if that's pressed in, that motor 1 is on direction reverse, and the speed is at 100. Now, for whatever reason, it's going the wrong direction, because of the way you might have, let's say, put the positive and negative onto the motor itself. You might need to change this around, so that you might need to change this to reverse and this one below here to forward, depending on it. But this should be right if you follow the wiring diagram that I've supplied. Okay, so now that we have some basic wiring done, I roughly put together a quick demonstration of the use of two separate limit switches in conjunction, I suppose, with this motor here. Now, as you can see, it's set up just like the wiring diagram. There's a battery going to our microbit and breakout board. We also have our motor block 1 being used to run this motor and gearbox, which is actually pushing this pencil, which is going to be going clockwise and anti-clockwise as it hits these limit switches. So now that we've figured out our code, uploaded it to our microbit, we can now turn it on. Don't be surprised if nothing happens. To start it off, what you'll need to do is you'll need to touch one of the limit switches, and it will start traveling in the opposite direction. So if I touch this one, start going down. Okay, so that's the demonstration. You can see how handy it is working with two limit switches, how you can get it to reset itself or change direction.